Okay, negative 10 times e to the 0.7 minus 6x minus 3 is equal to negative 38. So we got a little bit more going on in this one, but the same principles still apply. Variables in the exponent, we've got to get that exponential expression by itself right here. So we start, in this case, you always start with adding and subtracting. If that's an option, adding and subtracting always comes first. So we add the 3 to both sides, so we have negative 10e to the 0.7 minus 6x is equal to negative 35. Then we've got to divide by the negative 10. So e to the 0.7 minus 6x is equal to positive 7 over 2. Yeah. Leave it in fraction form. Okay, I know that that one's a terminating decimal, 3.5. Leave it in fraction form. That's how it's going to look on the answer key. Okay, so exponential, finally by itself, we're ready for log form. This one's base e, so we're going to use the common log. And I don't know about you, I always write the common log. I write it in cursive because my L's and my 1's look exactly the same. So if I write it in cursive, I have a distinguishment there. I don't get confused and think that that's a 1N or something like that. I mean, I really don't think that you would get confused, but I've just always done that. Pretty sure my teacher did that when I was learning about common logs or natural logs, and I just stuck with it. Okay, we need to subtract the 0.7. Again, that's 7 over 2, never, ever, ever changes. And we divide by negative 6. Here's another one, negative in the denominator. We don't like that, so we move it to the numerator. And I'm actually going to flip the order here, because you will see this frequently when one of your terms was already negative and you move that negative to the numerator and change both those signs. They're going to change the order so that they can save just that fractional amount of ink in printing a negative in front of the natural log and a plus in front of the 0.7. If they switch the order, then they don't need that plus sign. I know, kind of trivial, but that's how you're going to see it. Okay, so that's our exact answer. Let's find our approximate. 0.7 minus natural log 7 over 2 divided by 6. Notice I have parentheses around the entire numerator, stored as x. So there's our approximate answer. X is approximately negative 0.092. And we go to the original, negative 10 e to the 0.7 minus 6x. Close parentheses, minus 3. And that gives us negative 38. Okay, I want to do one more just to make sure I've got all my bases covered. This pretty much has everything that you could encounter in one of these problems. You've got a multiple, you're adding and subtracting the exponent. We've got a different log base. This one's got a little bit of everything. All right, so again, I'm going to keep reiterating this because I want you, this should be the thought process that you go through. When you are faced with any equation that you have to solve, you should think, okay, trying to get the variable by itself. What's the problem with getting the variable by itself? The problem here is that it's stuck in an exponent. If it's a polynomial, the problem is I have multiple variables. So I know that I have to factor, or I know that I'm going to have to use the quadratic formula, or I know I'm going to have to use long division and then the quadratic formula, okay? That should be the thought process that you're going through. With rationals, you've got denominators, so that's your problem. You got to get rid of those denominators. Here, you've got that exponent. You got to get it out of the exponent. So you've got to start by getting that exponential expression by itself. So we subtract 7. Negative 35.5. And divide by negative 9. I'm going to consult my calculator on this one. Will that turn into a fraction? Yes, it will. 71 over 18. Not a very pretty fraction, but a fraction nonetheless. A fraction prettier than that non-terminator, or that decimal there. Okay, so we've achieved our goal. The exponential expression's by itself. We got to get that variable out of the exponent, so we have to go to log form. We have a base of 6, so it's log base 6 of 71 over 18 is equal to 5m minus 7.6. Then we got a couple more steps to get the variable by itself. Add the 7.6. Again, never, ever, ever changing that 71 over 18. Put parentheses around it just to be safe. And then divide the whole thing by 5. That is our exact answer. Our approximate answer, we have to use change of base. Now, I would probably do this one in pieces just because there's so much that we have to do. We got to find the log, change of base, log of 71 over 18 divided by the log of 6. Then we need to add 7.6 to it, and then we need to divide the whole thing by 5. Now, it's not impossible to do in one step, but I would suggest chunking that. Do your change of base first to find the value of that log, then add the 7.6, then divide by 5. Okay, so notice how I did all of that in pieces. Change base, enter. 7.6, enter. Divide by 5, store as x, enter. So that x, or excuse me, m, is approximately 1.673. We've got negative 9 times 6 raised to the 5x minus 7.6 plus 7, negative 28.5.